What's up everyone, this is Ian with your daily FE problem. Today we have a thermodynamics problem. This is a problem that's covering energy balance for a steady flow device. So the device we have today is a diffuser. And a diffuser, just remember that pressure increases to cause the velocity to decrease. And yeah, so let's look at what we're given. We're given pressure 1, temperature 1, velocity 1. Pressure 2, temperature 2, and we want velocity 2. So let's look at these important equations that I wrote in for us. This is just telling us about energy rate. Energy rate in is equal to energy rate out. And when we make that bigger, really look at what's making the energy in these problems. We have heat transfer, work, mass flow rate, enthalpy, kinetic energy, and potential energy. Now the most important problem, or most important thing for these diffuser and nozzle problems is to remember what is negligible. So, heat transfer is negligible, work is 0, and potential is 0. So anytime you have a diffuser or a nozzle, you can know to cancel these things out, and all that you're going to be left with is mass rate in of enthalpy plus kinetic is equal to mass rate out of enthalpy and kinetic. And another helpful thing, when we look at this, we have one inlet and one outlet. So that just tells us that our mass rate is also going to be negligible. So really what we have is just enthalpy and kinetic. Okay, so this is H1, V1, H2, V2. Let's put our enthalpies on one side. So if we have H1 minus H2 is equal to kinetic 2 minus kinetic 1. And then let's look at this other important equation I have down here. For enthalpy, change of enthalpy is equal to Cp times T1 minus T2. Because we don't have enthalpy, we do have temperature and we can find Cp. So let's write this equation in for this. Cp of T1 is 30 minus T2, 90. Is equal to V2 squared over 2 minus V1, which is 350. Okay, we want to get rid of these fractions, so let's just multiply everything by 2. 2 Cp of negative 60 degrees Celsius is equal to V2 squared minus 350 squared, which is 120 to 500 meters squared per second squared. Okay, so what is our Cp? For Cp, we have to go to our steam tables. We're just hopping to the screen recording real quick. So our T average is our two temperatures added up and divided by 2, which gives us 60 degrees Celsius. And to convert that to Kelvin, we just add 273. So our temperature in Kelvin is 330. So we have to interpolate what the Cp value would be for 330. So we look at our table for ideal gas of air. We have 350 and 300. So those values of 1.008 and 1.005 are going to help us find the Cp for 330. So really quickly, I'm just going to show you how we interpolate. We have 350 minus 300 over the corresponding Cp values, which are 1.008 minus 1.005. And we just set that equal to 350 minus our R value, which is 330, over 1.008 minus X. So when you solve for that X value, that's how you get your Cp for 333. And I think that comes out to being 1.0068 or just 1.007. And that's how we get our Cp value. Now I'll see you back in the video in person. We get Cp is equal to 1.007. So we have 2 times 1.007. The units for this is kilojoules per kilogram times degrees Celsius times our -60 degrees Celsius is equal to V2 squared minus. Now, another important thing from this problem is for units. Meters squared per second squared is the same as joules per kilogram. So we can rewrite this as 122,500 joules per kilogram. If we look at the units on the left side, our Celsius is going to cancel out and we're going to have kilojoules by kilogram. So all we have to do is multiply this value by 1,000 to get this also in joules per kilogram. So if we do that, multiply all of this out, we have -120,816 joules per kilogram, because the Celsius is going to cancel, and then we multiply by 1,000 to get the joules, is equal to V2 squared minus our value that we have from before. Now if we want to solve for V2, we're going to have the square root of 1,660 joules per kilogram. So how is velocity going to equal joules per kilogram? Well, remember, joules per kilogram is meters squared per second squared. So when we square this value, we're going to end up with meters per second. And that's going to be 41.04 meters per second. So there you have it. That's our video for today. Just remember important things like your units, your equations, how work and heat transfer and potential cancel out for diffusers and nozzles, and you guys will be set for your problem. Thanks for watching. From the ring to the stream, I'm the king.